13.1 Trigonometry with Right Triangles. Today's comic, courtesy of SoMuchPun.com. I'll come back to it in a moment, but let me first get to right triangle definitions of trigonometric functions. If we let theta, and we call this symbol right here, that's a Greek letter, and it's theta, be an acute angle, acute meaning less than 90 degrees, let theta be an acute angle of a right triangle. So we must have a right triangle. The 6 trigonometric functions of theta are defined as follows. Sine of theta is opposite over hypotenuse. So when we have a triangle, and here is theta, this is the opposite side, and the side touching the angle is called the adjacent side. Of course, the one opposite the right angle is always our hypotenuse. So we have an opposite, we have an adjacent, and then we have the hypotenuse. And so the sine of theta is defined as opposite over hypotenuse. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is just the opposite over the adjacent. And then we have the reciprocal of all three of those. And those are cosecant, secant, and cotangent. You might want to take a note of those if you don't know those names, because you do need to know cosecant, secant, and cotangent. Cosecant is simply 1 over sine. In other words, hypotenuse over opposite. Personally, I barely ever think of it as this. I just think of cosecant as being 1 over sine. Secant, 1 over cosine. Cotangent, 1 over tangent. Something you might want to note is that the S1 goes with the C, and the C over here goes with the S1 over here. That makes my life a little bit easier. That's how I remember it. And then tangent and cotangent are so obvious. I wish they were all named so well like that. Some of you may have heard SOHCAHTOA. SOHCAHTOA is a way to remember that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So that's SOHCAHTOA. It's a way to remember sine, cosine, tangent. Now there are 2 special triangles, and you do need to memorize these properties. This is very, very useful for your SATs also. This is something you definitely need to know. In both of these triangles, let's just call the hypotenuse 1. If the hypotenuse is 1, then the ratio of these sides can be defined as the one opposite the 30 degrees is 1/2. The one opposite the 60 degrees is root 3 over 2. You do need to memorize these ratios. Opposite the 30 is always going to be 1/2. Opposite the 60 is always going to be root 3 over 2 if the hypotenuse is 1. So any 30, 60, 90 triangle that you have would be in these same proportions. I could give you a different hypotenuse. Say this is 60, this is 30. I could say that the hypotenuse was 6. Well, then this side would be 1/2 of 6, or 3. And this side would be root 3 over 2 times 6, or 3 root 3. So if you just memorize this one, then you'll have any 30, 60, 90 triangle covered. You also need to know the 45, 45, 90 triangle. Note that these are the same angles, so these sides must be the same length. Remember that from geometry? The ratio here goes, if this is 1, then this is root 2 over 2, and this is also root 2 over 2. Now that we have that basic information filled in, let's go ahead and find the sine, cosine, tangent, cosecant, secant, and cotangent of each of these angles. Let's first look at 30 degrees. Well, the sine of 30 degrees is going to be opposite, which is 1/2, over hypotenuse, 1, which is just 1/2. The cosine is going to be adjacent, the one touching it, root 3 over 2 over hypotenuse, which is 1. So that's just going to be root 3 over 2. The tangent is going to be opposite, which was 1/2, over adjacent, which is root 3 over 2. So let me just take that math up here. 1/2 over root 3 over 2 is 1/2 times 2 over root 3, which is 1 over root 3. Remember that we cannot have radicals in the bottom, so to rationalize the denominator, we'll multiply by root 3 over root 3, and we're left with root 3 over 3. So the tangent is root 3 over 3. To get the cosecant, I simply flip sign, so 1/2 flipped is 2 over 1. Secant, flip this, I get 2 over root 3. I do need to rationalize this denominator. And so I get 2 root 3 over 3. Now to get cotangent, I want to flip tangent. But if I flip this, I'll note that I have a radical in the bottom. So I'm actually going to look back up here. And you'll notice before I rationalized, I had 1 over root 3. So if I had flipped that, I just would have gotten root 3. And anybody who doubts me can try flipping 3 over root 3 and rationalizing the denominator. You're going to get root 3 also. So one little tip that I do have that I'll point out later on is that you do show all your work along the way so that when you have to go back and flip, you might have the answer sitting there before you rationalize. I'll explain that more as we go on, but I would recommend showing all my work. To get the sine of 45 degrees, well, that is opposite over hypotenuse. Root 2 over 2 over 1, which is just root 2 over 2. The cosine is the same thing since they're the same side lengths. The tangent is just going to be root 2 over 2 over root 2 over 2. Anything over itself, of course, is just 1. Now I'm just going to flip all these things, so I get 2 over root 2. I do need to rationalize this. So I get 2 root 2 over 2, which simplifies down to just root 2. Well, secant's obviously going to be the same thing since sine and cosine were identical, so I'm not doing all that work again. Cotangent, just flip over 1, which is still 1. Finally, let's do all the same work with 60 degrees. Opposite, root 3 over 2. Over hypotenuse, that's just root 3 over 2. Cosine is adjacent. Adjacent to the 60 degrees is 1/2. Over 1 is just 1/2. Tangent is going to be root 3 over 2 over 1/2. Opposite over adjacent, which is, let's do it up here, root 3 over 2 over 1/2. So times 2 over 1 is just root 3. Beautiful. And then I've got to flip these things. I've already done this work before, so I'm going to look back at what I did. Before I flipped root 3 over 2, and I got 2 root 3 over 3. So I'm copying my work from up there. Flip 1/2, and I get 2. Now let's flip root 3. Did I do that before? Oh, look, I had root 3. Root 3 flipped was root 3 over 3. So I kind of just looked back at my old work to get that done. You could have redone it all, and you might start seeing some emerging patterns happening here, but I'll leave that for you to explore for right now. Let's go ahead and evaluate the 6 trigonometric functions of this triangle right here. So they were sine, and you do need to know these, cosine, tangent, and then I usually just put cosecant, secant, and cotangent over here because I'm just going to flip these things. Remember, the S goes with the C and the C goes with the S. So sine is opposite, which is 7, over hypotenuse. What is the hypotenuse? Remember a squared plus b squared equals c squared? Yep, it's all coming back. 7 squared plus 24 squared equals c squared. Let's see, 7 squared plus 24 squared is 625, and the square root of my answer, remember this second answer, that's going to come in handy here, is just 25. C equals 25. So 7 over 25, and then cosine is going to be adjacent, 24, over hypotenuse, 25. Tangent's going to be opposite over adjacent, 7 over 24. And then just flip them all, 25 over 7, 25 over, and 24 over 7. Next problem, if theta is an acute angle of a right triangle, okay, theta, there we go, right triangle, and cosine is 3/5. So cosine, this is the adjacent, and this is the hypotenuse to theta. So which leg is touching theta? This leg right here. So that's 3. Which side is the hypotenuse? This one, of course. And hopefully you know your 3, 4, 5 triangles. That's another important one for your SATs. You should know 3, 4, 5 triangles. They always work. What is the value of cosecant? So remember, cosecant of theta is 1 over sine theta. So what is sine theta? Sine is opposite, which is 4, over hypotenuse, which is 5. Therefore, cosecant would be 5/4. Now we have to find x, which is this side length. Well, let's think about which of the 6 trigonometric functions we might want to use in this case. In our problem, with the 45 degrees, we have the adjacent side and we have the hypotenuse. Since we have information for adjacent and hypotenuse, we know we should be using cosine. What is our angle in this case? It's 45 degrees. So the cosine of 45 degrees is equal to x over 6. Do you remember what the cosine of 45 degrees was? If not, look back at the table we made. Cosine of 45 degrees was root 2 over 2. So we have root 2 over 2 equals x over 6. Let's go ahead and multiply both sides by the common denominator, which is just 6. So those cancel, and we have a 3 left. And so we have 3 root 2 is equal to x. In this problem here, we have our 30 degrees. Again, we have adjacent, and we have hypotenuse. So again, we're going to be using cosine, but this time the cosine of 30 degrees equals x over 8. Go back to your table. The cosine of 30 degrees was root 3 over 2. So we have root 3 over 2 equals x over 8. Let's go ahead and multiply both sides by the common denominator, which is 8. And we get 4 root 3 is equal to our missing side length. In this problem here, oh my goodness, we have cosine again because it's the adjacent that's given. So the cosine of 54 degrees is equal to b over 20. Now in this problem here, I don't have my table to figure out what the cosine of 54 degrees is, so we are going to need to use our calculator. Before I do that though, let me just multiply both sides by 20 because that's what b is going to be equal to. So I'm going to have b equals cosine of 54 degrees times 20. So go to your calculator. The first thing that's really important in this section is that you're in degree mode. So to make sure you're in degree mode, go to mode on your calculator, which is right here, and make sure that you're in degree mode. So right now I'm in radians, which is not good for this problem. I need to be in degrees. So just go down to it, go over, and press your enter button, and then second quit, and you'll be in degree mode. Make sure you have that for all of these problems, otherwise you're going to get all of the wrong answers. So the cosine of 54, we must have that in parentheses, cosine 54 times 20. So we had b is equal to 11.756. We also need to find a. There's two ways to find a. We could use a Pythagorean theorem, do a squared plus b squared equals c squared, but I think in this problem it might be easier to just use sine, that the sine of 54 degrees is equal to a over 20, because the sine is opposite over hypotenuse. So again, I'm going to multiply both sides by 20. So I'm left with a equals sine 54 degrees times 20. And when you do that in your calculator, you should get 16.180. In this problem here, I have the adjacent angle. So my only trig functions to choose from would have to be cosine or tangent, because those were the only ones that had adjacent in them when solving. So that's how you choose which trig function you should use. So I'm just going to start with cosine of 28 degrees is equal to 15 over hypotenuse, which is c. Let's go ahead and multiply by c on both sides. So I have c times cosine of 28 degrees equals 15. Of course, I want to solve for c, so I'm going to divide both sides by cosine 28 degrees and go over to my calculator. 15 over cosine 28, and I'm in degree mode, so I'm good to go, is equal to 16.989. Now to find c, I could use tangent, the other one, 28 degrees, is equal to opposite, which is a, over adjacent, which is 15. Multiply both sides by 15, giving us a is equal to tangent of 28 degrees times 15, or 7.976. Last problem. You are hiking towards a main road, but reach a point where the road is flooded. To avoid the flooded area, you turn into a diagonal road that meets your original road at a 48-degree angle and follow that road for 3.6 miles until you hit the main road. Okay, so let's draw this out. So you're hiking, here's this main road, and you're hiking towards it. So say you're going this way. So you're going along the road, and then you hit this spot, and it's flooded all here. And so you turn onto this diagonal road that's going to meet the main road somewhere. And you turned on a 48-degree angle, it said. And you go on that road for 3.6 miles until you hit the main road up here. And so that's going to be perpendicular to that, because the shortest distance is always the perpendicular distance. We know that we have an angle and we have a hypotenuse. And we want to find how far away we are. That shortest distance is a perpendicular distance, so that's why we made the right angle there. And so we want to find x. And so x is actually the adjacent leg of this triangle. And so we must use cosine of 48 degrees equals adjacent over hypotenuse, which is 3.6. Let's go ahead and just multiply by that 3.6 on both sides. And so we get x equals cosine 48 degrees times 3.6, cosine 48 times 3.6. And so we get 2.409 miles. Oops, I lied. One more question. From a point on the ground, 28 feet from the base of a flagpole. Okay, so we have a flagpole, and we are 28 miles away from the flagpole. The angle of elevation to the top of the flagpole is 63 degrees. So that's the angle of elevation there. Estimate the height of the flagpole. So we want to find x. So in this problem right here, we have opposite and we have adjacent. So since we have opposite and adjacent, we should be using the tangent of 63 degrees is equal to opposite, which is x, over adjacent, which is 28. Multiply both sides by that 28, and we get x equals tangent 63 degrees times 28, which equals tan 63 times 28, 54.953. So I'm just going to say on this one, about 55 feet. So now that we know the definition of sine, cosine, and tangent, we will know that sine gerene over cos gerene is equal to tan gerene. Ha ha ha. Make sure, though, that you note you're not crossing out these gerenes, because remember, sine and cosine are both functions, and so it's not sine times gerene over cosine times gerene. The sine and the gerene are attached, so we get tangerine.
And that's it for this lesson. Bye.